Hello, dear friends, my dear students of 4th semester electrical engineering as well as electronics and telecommunication engineering. Once again, I am here with you, Mr. Lalit Kumar P BHAIYA, Associate Professor, Electronics and Telecommunication Engineering Department. Dear students, last time, that is in last video, we have seen a numerical on voltage shunt feedback amplifier, that is unit 4 of you, with single stage. We have considered last time a single stage amplifier, common emitter amplifier. Along with the feedback, we have identified the topology and solve the parameters like voltage gain, current gain, input impedance, output impedance with and without feedback, etc. of the single stage only. Now today we will go to the two-stage amplifier problem. It is a multi-stage with feedback having the same topology, that is voltage shunt feedback amplifier, but the numerical is of two-stage amplifier. Let us go now for this second stage amplifier. Last time we have seen this problem. This problem is a single stage with this feedback circuit. Here output is voltage and the input is the feedback. Output voltage is the input to this feedback circuit and this is the output current of the feedback circuit, which is in parallel with this Norton equivalent of this source Vs and Rs that is shunt circuit, and hence it is voltage shunt feedback, and we have calculated number of parameters of this circuit. Now let us go for the second example of this circuit. Now see this one. This problem is the two-stage amplifier shown in figure below has identical transistors with the parameters HIE is equal to 2K, HFE is equal to 100 and HRE is equal to 0. Calculate part A AVF, part B RIF and part C R-OF here. And this is the circuit. You can observe here. Now two stages are given. Here, this is the common collector stage, first one. And this common collector has the output at the emitter. And this output with coupling capacitor is connected to the base of the second transistor. And this transistor is the common emitter transistor with output at the collector. So this is common collector, this is common emitter. Common collector followed by common emitter, and output is taken here. And this output is connected to the input of the first stage with a feedback resistance R here. This is 2.2 kilo ohm resistance. Now this is called as the feedback amplifier. The first step is to identify the topology of this feedback amplifier. I have already told you I will take the problem of this two-stage amplifier of voltage shunt feedback. So topology, of course, it is a voltage shunt. But how to identify this voltage and shunt? In the same fashion, just like we have seen in the first numerical, that is single stage transistor, this is also the output is across this RC2 is the voltage, and this voltage will provide the current to this feedback circuit, that is 2.2 kilo ohm resistance, and hence this current will be flowing to the input side. Now what we have to do, output is voltage, output means the output across this RC2 is the voltage here, but this is the input to this feedback circuit, and this input which is equal to the output produces the feedback current here, and feedback current is the output of the feedback circuit, and this current will be in parallel with the current source prepared by this voltage source and resistance, that is Norton equivalent. So current due to Norton equivalent here is parallel to the current IF here, and hence here it is a shunt and here it is a voltage. So this is also a voltage shunt feedback. That is important to identify the topology. So given numerical, given circuit is a voltage shunt feedback. Now first step, which I have already told you, that is identify the topology. Here output voltage is sampled and fed in the shunt with the input signal, such that this IF is equal to II. Hence topology is a voltage shunt feedback. Now second and third step is to draw the equivalent circuit at the input and equivalent circuit at the output. Now method is same. To find the input circuit, output should be shorted, and to get the output circuit, input should be open. So in original circuit, make the input open, you will get this feedback resistance is connected like this, 2.2 kilo ohm, that is R. R is connected to ground, which was earlier connected from this collector to base of this transistor. Now if we keep this open, this will be grounded, so this resistance will be appear here at the output side. Now to get this input equivalent circuit, make the output shorted in the original circuit. Make the output shorted, then what will happen? The feedback resistor over here was in parallel here. Feedback resistance was here, then it will come in parallel to here with this Norton equivalent. This is the Norton equivalent, IS and RS, and this is the feedback resistance which is in parallel with this Norton. So this is the input equivalent circuit, this is the output equivalent circuit, and you got this input and output circuits also. This is very important step to determine the input and output circuit. Once you get this circuit, then it is easy to get the parameters. First of all, you convert this into the H parameter model, and connect these resistances to the H parameter model, and mark the input impedance, output impedance of the transistor 1, input impedance of the transistor 2, output impedance of the transistor 2, input impedance of the transistor 2, output impedance of the transistor 1, input impedance of the transistor 1, overall input impedance, that is with feedback, and overall output impedance, that is with feedback. Mark this parameter. Now let us see this parameter diagram. You can see this replacement with the H parameter model. Replace transistor with their H parameter equivalent circuit. So here this is the transistor 1 equivalent circuit, and this is transistor 2 equivalent circuit, H parameter model. This is the RE1 parallel to HIE, and this is the current source HFE into IB1. This is the current source HFE into IB2 second transistor, and this is the feedback resistance 2.2 kilo ohm, and this is the collector resistance 5.1 kilo ohm. Similarly, this is the source, this is the resistance connected here 2 kilo ohm, and this is the feedback resistance 2.2 kilo ohm, and this is the Norton equivalent. So in this way you can draw this H parameter model. Mark here Ri. This is the Ri1 of the transistor. This is the Ro of the first transistor, Ro of the output impedance of the circuit, and this is Ro dash equivalent output impedance. Similarly, you can mark the input and output currents. So once you get this transistor parameter model for the two-stage now you can calculate the open loop transfer gain. What is the open loop transfer gain here? This open loop transfer gain, you have to calculate this. Sorry, just a minute please. Open loop transfer gain, you have to calculate the RM. Since it is a voltage shunt feedback, the trans resistance is the gain. Hence, you have to calculate the RM and RMEF. So here, first step is to calculate this RM. RM is equal to this V naught by IS, output voltage upon input current, and this is equal to RC2 into I0 upon IS. Now this I naught upon IS can be categorized into four terms. I naught upon IV2, that is output of the second transistor and input of the second transistor. This is input of the second transistor and output of the first transistor. This is output of the first transistor and input of the first transistor. And this is input of the first transistor and source current. So these four factors are there, out of which you calculate this first I naught upon IV2, output of the second transistor to the input of the second transistor. So for second transistor, the current gain is given by minus HFE into R upon R plus RC2. R plus RC2. Now what is R? R is given as 2.2 kilo ohm. So you can calculate this value, put the values, you will get here minus 30.137. Now this factor, IV2 upon IC1 into IC1 upon IB1. This is equal to 1 plus HFE into RE1 upon RE1 plus HI. All values are known. Put these values, that is 30.84, and the last factor you have to calculate IB1 upon IS. Looking at the circuit, you will get it is equal to RS parallel to R and RS parallel to R plus RI1. RI1 is with the standard formula of the H parameter. It is RI1 is equal to HIE plus 1 plus HFE into RE. Put the values, this is equal to 113.1 kilo ohm. And then they calculate this ratio IB1 upon IS. This is first stage input current and this is source current. Put all these value, you will get this is 6.04 into 10 to the power minus 3. And finally, you calculate this value of RM by putting these values. That is four factors, four ratios. You will get this is minus 33.539 kilo ohm. So once you get this RM, then calculate the beta factor. So to get the beta factor, this is the value of RM here again calculated completely, minus 33.539 kilo ohm. Then beta factor is IF by I naught. IF is VI minus V naught and this I naught is V naught by R. This is minus 1 by R due to V, because V naught is very greater than Vi. So this value comes to be minus 4.545 into 10 raised to minus 4. So dear friends, you got these two values, beta factor and RM. Now you calculate the value of D. It's called as a return difference. 1 plus, in general we can write D is equal to 1 plus A into beta. So in place of A, it is voltage shunt feedback, we have calculated RM. So in place of A, RM should be written. Put the values, calculate the D factor, this is 16.2445. Calculate the closed loop transfer resistance, that is RMF with feedback, RM by D. Put the value, you will get minus 2.065 kilo ohm. Then AVF, voltage gain with feedback, output upon source, V naught upon IS into RS, and this V naught upon IS into RS is RMF by RS, and this value comes to be 2.065. And RI is the RS parallel from the circuit. You can observe RI is equal to RS parallel to R parallel to Ri1. This is 638 ohm. And then calculate input impedance with feedback, that is Ri by D, Ri upon 1 plus Rm into beta. So this factor already calculated. This comes to be 42 ohm. RO is infinite open loop. Hence ROF will be infinite by D. It is also infinite. But overall effective output resistance is R-O without feedback. Looking at the circuit to the output side, we will get R parallel to RC2. And R is given, RC2 is given, parallel combination is 1.537. And finally, R-OF is the output resistance of overall two-stage amplifier with feedback, is R-O upon D. R-O calculated and D is this one. So this value you can calculate here, R-OF. In this fashion, you can calculate R the parameter and get the answers. Kindly go to the given problem, please. Thank you very much, and I request you all to go such type of various numericals, and if you have any doubts, feel free to ask me at any time on any platform. Thank you very much.